Hello, this is Chris Maynor. I'm coming to you from my office here on the campus of Union University in Jackson, Tennessee. In this video, I want to review a couple of principles that we've looked at already and use this review as a segue into a new topic, competitive short-run supply, or more simply, the supply curve of a perfectly competitive firm. So, let's first review what we call the profit maximization rule. I've borrowed this from Chapter 3 in our textbook. The profit maximization rule says that firms maximize profits by choosing the highest level of output at which marginal revenue is greater than or equal to marginal cost. Again, this is borrowed from Chapter 3. Chapter 3 refers to this as the principle of unconstrained optimization. I've paraphrased it somewhat. We might call this the general form of the profit maximization rule. It always works. It applies in any situation. If you have ever taken an undergraduate principles of economics course, you may have heard a more simplified version of the profit maximization rule. I'll call it the simple form of the profit maximization rule, that firms maximize profits by choosing the level of output where marginal revenue is equal to marginal cost. Now, this simplified version is much easier to remember. However, it sometimes leads to confusion. It sometimes leads to problems. You'll notice that the simplified version leaves out two phrases or two parts of the general rule. This phrase, the highest level of output, and then it also leaves out the possibility of the inequality here. So again, the simple version, the version that you may have learned as an undergraduate, can create some problems. Let's look at a couple. Let's suppose that we have a marginal revenue, marginal cost schedule like this one. This is the schedule, say, for a perfectly competitive firm. A perfectly competitive firm faces a market price equal to 9. Notice that this is constant for any quantity from 0 to 8. The firm can sell their goods at $9. Price equals marginal revenue. And then we have the firm's marginal cost schedule. If we were to use the simple profit maximization rule, we might run into some trouble, because you'll notice at no point is marginal revenue equal to marginal cost. And so at first glance, it might appear as though that this firm is not able to optimize, is not able to maximize its profits. But remember the general rule. We look for the highest level of output at which marginal revenue is greater than or equal to marginal cost, and that occurs at a quantity of 4. At 4 units, marginal revenue is 9, marginal cost is 8. We wouldn't go to 5. We wouldn't produce the 5th unit, because at that point marginal cost exceeds the marginal revenue. That 5th unit would be unprofitable. So the firm maximizes profits by producing 4 units. And again, we used the general form of the profit maximization rule. This is a situation where we have what is called discrete mathematics. There are gaps between these values of the marginal cost. And so marginal cost is never equal to 5 or 5.5 or 5.578. There are discrete gaps in the schedule, and in that case, very often we have to use the general form of the profit maximization rule. Here's another situation. This is a graph, and notice that the marginal revenue schedule, the marginal revenue line in green, and the marginal cost schedule in blue, notice that they intersect at 2 points. We might say this point, we might call that Q1, and this other one, it's already labeled, let's call that Q2. Now you might think, if you use the simple version, the simplified version of the profit maximization rule, that there are 2 optimal quantities. No, there isn't. There's only one, because we always seek out the highest level of output at which marginal revenue is greater than or equal to marginal cost, and that would be at Q2. What's wrong with Q1? Well, for one thing, price at Q2 is less than the average cost, so the firm would have a loss. And the reason is because the firm is operating in what we call stage 1 of production. We haven't reached that point where diminishing returns have set in. So we always seek out the highest level of output where marginal revenue is greater than or equal to marginal cost. So I hope that review helps. Now, in the previous lesson page, we looked at the shutdown rule. The shutdown rule can be thought of as 3 parts. As long as price is greater than average variable cost, the firm should continue to produce in the short run, even if they are earning a loss, even if price is less than average total cost. If price is less than average variable cost, the firm should shut down. They're going to lose money, but the losses are less by shutting down than if they continue to operate. And then if price equals average variable cost, if the 2 values are the same, then the firm has reached its shutdown point. And at that point, it really doesn't matter what the firm does. Whether it produces or shuts down, its loss will be the same. Its loss from operation will equal its fixed costs. And so again, we call that point the shutdown point. That price where price equals the minimum average variable cost is called the shutdown price. So let's look at this graph and let's apply what we just learned. Let's suppose this perfectly competitive firm faces a market price of $2.60. If that's the case, we see that marginal revenue will equal marginal cost at a quantity of 1,100. So at a price of $2.60, the firm produces 1,100. Now, what I've created here, or I'm starting to create, is a table. And in this table, we're finding price-quantity combinations. We're finding the quantity of output that the firm is willing and able to produce at a particular price. So let's try another price. Let's go to $1.60. At $1.60, marginal revenue, marginal cost would be equal, well, I don't have an exact value here, but let's say that's, maybe, I don't know, maybe 900. We'll call it that. I'm sort of guessing somewhere between 800 and 1100. If the market price falls to $1.50, the firm is at its break-even point, earning a normal profit. Price equals average total cost. The firm produces 800. If we go even further, if we, for example, have a market price right here at the minimum, the lowest point on the average variable cost, that's probably about 75 cents. If the market price falls to 75 cents, then the firm will do one of 2 things. It'll either produce 0 units. Why? This is the shutdown point. This is that point where price equals the minimum average variable cost. And so it doesn't matter whether they produce 0 units or whatever that quantity might be, maybe 550. So 0 or 550 units, again, it doesn't matter. Their losses will be the same. Their loss from operation will equal their fixed costs. So what do we have here? we've created a schedule that tells us the quantity that firms are willing and able to produce at each and every price. So what is that schedule? What tells us, what kind of a schedule or what kind of a graph shows us the relationship between price and quantity produced? Well, that is a supply schedule. We have derived the firm's short-run supply schedule. So let's put this into words. A competitive firm's supply curve is the portion of the marginal cost curve for which marginal cost is greater than average variable cost. It's that portion of the firm's marginal cost curve that lies above average variable cost. Now you might want to pause here and take note of this, but let's go ahead and see what that means. If I were to shade in the portion of marginal cost that lies above the average variable cost. Notice I did not shade in this lower area here. I did not go below the average variable cost, but this area that's shaded in is the competitive firm's short-run supply curve. It's that portion of short-run marginal cost that lies above the average variable cost. And again, only that portion above average variable cost. Any point below the quantity supplied is equal to 0. So this is a nifty little application of the shutdown rule. And again, this is a derivation of the competitive firm's short-run supply curve.